Hey.
What?
Hey, George.
Hey guys, couple little updates.
Morning.
Yeah, with me?
I'm with you.
All right. So first thing, as you may or may not know, I am in no legal obligation to record my classes because I don't have a virtual calculus. But I do that. But what I'm going to do now, I've finally rigged up a little system for me to just run a Google Meet all day. So if you're absent, you can just hop on to that same, if you want to write this down, do you remember what it was that I used all the time?
No.
It was hurry_meet_2020. I know it's no longer 2020, but I'm sticking with it. Okay, so anyway, you can just, if you're absent or on vacation or skiing or whatever it is you might do, sick, quarantined, I'm still going to do my best to record them, all right, because it's what I'm doing is working. So I'm just recording the Google Meet, but I don't know, sometimes it takes 20 minutes for that recording to be processed and emailed to me. Sometimes it takes 8 hours. So I've run a couple of tests. It just depends on, I guess, how busy they are, or maybe if they have glitches going on. So normally when I use my phone, which I'm not doing, it's kind of freeing. But normally I do that, and granted there's some upload time on that as well, but it's fairly consistent. The Google is not. Now I did my first period class and it uploaded in, I don't know, 10 minutes. So it was pretty great. But again, yesterday, a couple days prior when I was recording them, sometimes I wouldn't see them until 4 that night. So anyway, my point is, if you are absent, go ahead and just log into the class. If it's not running, which it should be, but if it's not, then just call my phone. And all of you have my number. Just call it and say, hey, your meet's not running. Or call it and then text me if you don't want to talk. I know people don't like to talk on the phone these days, but call it and let it ring so I look at it because I won't hear it. But anyway, whatever. I'm going to be running them like it's running right now. And if you're at home, you're welcome to do that, which kind of frees you up.
Is there anyone at home right now?
No. So I'm just literally doing it to record at this point. I don't think so. What happened to Nolan?
He has COVID. He got.
Oh, he does have it. I never got an email about it.
That's not. He had it. He's coming back in like a week. I mean, he didn't get it like from the school. I don't even know if he reported it, but he did test positive.
Okay. Well, then he'll see this video. Nolan, hopefully you're watching. So if you are, that's how you can log in. If you watch this video later, that's how you can log in on Monday or whenever. Okay?
Today is his last day.
Is it? Okay. Yeah. No, I normally write it down in my book when I get the email. I write down the cues all the way through, and I don't have anything for him. But you're right. It has been noticeably less entertaining. No one brings entertainment to the class.
I don't fulfill your need.
I'm sorry?
I don't fulfill your need.
I don't think I'm deaf.
I fulfill your need.
Oh, no, you did a good job. No, y'all are really, this class, my 5th period class, my junior classes are really sweet people. They don't talk much to me. You guys, I have a lot of fun with.
Are we not really sweet people?
No, you guys, I have more fun with. There's a lot more interaction. And granted, you've known me longer, but and the sophomores, especially that 5th period group, if you walk in here, they're funny. Yeah, your brother's in there. I don't know if you know. Yeah, he's funny. Pozo, I don't know if you know Martina Pozo.
Oh,
that girl is a steady stream of entertainment all day long.
Oh my God.
But there are a number of people in there that, there's a lot of people in there that provide. But some other classes, they're just staring at me. So, which is okay. Some teachers love that, but I like the dialogue. All right, so we've got a test coming up, right?
Yeah, next Thursday.
No. All right, so our test is on Monday. I've gone through I had a bunch of stuff I was looking at doing today, and I just kind of went through and just kind of hand-picked some different things. I just wanted to point them out. Again, a lot of this is going to seem like we've done it a million times and we have. I'll probably rethink how much time I spend on this next year because it is a little extra. But what's not broken often doesn't need fixing. So I'm looking at your book. I'm guessing 75-ish.
Yeah.
That's like in the middle of something.
73.
Maybe not 75.
Probably 73-ish.
77.
Notes, homework, conditional fields.
Yeah, this is it. Okay, yeah, so it's page 73. So we're looking at page 73, and again, hey guys, I'm going to hop around from problem to problem. Not to suggest that some of these are bad, but I'm just going to hop from problem to problem to try to get in a little bit. So I'm jumping to number 4. Okay, so here on number 4, it says, and I'm going to give you better looking slope fields than your calculator produces. So like your calculator on number 4 here, if you're looking at, and I think you can see this pretty well on your printout, but as you're looking at this, what does it look like the slopes are doing here on the left?
Just
Part of me thinks 0, but the other part of me feels like it has a little tilt to it, doesn't it? Like this, so it's slightly positive. And then over here, it looks like it has a little positive and it clicks to a negative. That's what it looks like your calculator has done. But very clearly up here, if I plug a positive, say, +4 in there, I'm not getting a negative number. So I don't know why it tilts down like this. So again, I don't think you have to worry about that on your test, but should that ever happen, remember that you not only have a slope field, but you also have the equation. So if I'm looking up here and I'm in doubt at all about what to do, remember I can, if I have the equation, I can look at both. Are you with me? Yes.
will we ever have to produce slope fields on our calculator?
No. In fact, I gotta be honest with you, I couldn't do it right now. I figured out how to do it and then I've totally forgot. Like it's not like the super easy to find. You have to actually kind of hunt for a little bit. I mean, you can find it and you certainly can Google and or whatever, YouTube video and somebody will show you how. But anyway, so right here I said passing through 0, 3, 1, 2, 3, it says sketch the solution, the particular solution. So I actually needed a little help on this because I'm looking at this and I'm thinking, wait a minute, is that 0 all the way across? Do I just have a horizontal line? So what I did is I actually used this to think, okay, what would have happened if I was coming up this way? If I was coming up this way, it kind of looks like I would have bent and flattened out, right? So, right? So I kind of thought, well, which of those, like if I came through here, my conclusion was I wouldn't have hit that point. If I came through here, probably not. And I just kept thinking, what would have gotten me to that 3, 0? And I really ended up more like over here. I figured I would get to that. So I kind of visualized, and this was a little harder sketch. The slope fields I'll give you on your test are not that difficult, okay? But remember, on a test, if I have the equation, I could really get a better idea about what these slopes are by plugging in random values. Are you with me on that? Okay, so anyway, this slope field is a little trickier, I think, to solve right here, but it kind of looked like probably flattened out like this, kind of came in here. And again, when I look back at my graph, it should look like I'm not really crossing through stuff. These really should be bent a little bit more. They really should be on this right here. They really should look more like that. But your calculator, for some reason, just didn't do a great job with some of these. And but anyway, once I get down here, you see, do I keep going? What's wrong with this? At some point I went vertical, right? And you've got to remember, it's so easy just to curve along there. If you ever find yourself going vertical, you stop right there, open circle. So you got to be careful about some of these. Again, I wanted to point that out again. If I gave you 0, -2, to find that one, which would be a totally separate graph, it doesn't mean both, okay? So 0, -2, what do you see going on here? What does it look like the right side and the left side are doing right here? Anything? It looks like they're kind of, yeah, they're going a vertical right there somewhere. So when I looked at this, I thought, okay, if I'm sketching this, I'm trying to draw my line, which is kind of the average of the slopes on either side. It looks like it's kind of diving down towards a vertical through there. But then as you come up, does this make sense, kind of what I'm doing? I'm coming up, but do I want to keep doing this, what I'm doing? You see where I went wrong again? Yeah, as soon as you see that I'm hitting that vertical, you got to freeze it, discontinue the graph. So again, it's really easy to kind of just start following along, but you can follow along until you hit a vertical. But if I hit a vertical right there, which it looks like at some point, if I'm rounding the bend right here, I've got to go vertical somewhere. Wherever that happens, you feel like that is, not like, well, I felt that. I mean, you got to feel and be right, but somewhere in that neighborhood, we're going to have to go vertical. Are you with me? And as long as you're close, but I think it's a lot more clear on the ones like, it's really hard to create these. I mean, there are programs out there that do them, but some of them, they just put so many in there. It's just mind numbing, or they put so few. So I've kind of kept kind of a family of them that I use, the good ones, the really better ones for your test that I think are a lot more clear and that yield better results for my students. So you tracking with me?
Tracking.
Okay, so that's number 4. I think I wanted to look at number 5 as well. So number 5 said, says on a copy of the slope field to the right. I don't know what that even means. I probably just copied it down, but whatever. On that slope field right there, sketch the 2 particular solutions to this differential equation going through 2, 2, and -3, 0. So again, at 2, 2, 2, 2, you see what you're doing? Just diving downward, right? So again, kind of following that out. Looks like it's just kind of going, kind of keep it in between the lines there. But at some point, you can see all these are channeled to an undefined. And that should make sense. When you look back up here at x = 0, you can see that it's undefined, right? So that's very convincing there. And then through -3, 0, which is right here, again, these look like they're just following that out. But at some point, just following that down. So anyway, hopefully you're good at the sketching. You're not going to have a ton of that kind of stuff. But and again, as long as you're pretty close, you start getting really off. Or if I see this, if I see your line kind of going right through a slope like that, then that's off. You shouldn't ever see where it's actually going right through something, because you always should be kind of splitting the difference. Like if I'm heading through there, don't do this kind of stuff. Say, wait a minute, I got to keep it kind of in between there or on there. You should always feel like it's kind of just guiding it, you know? So anyway, jumping past that, let's look at, because there's way more than I really want you to do tonight. Number 7 says on the slope field above, sketch the solution going through 0, -2. So this is number 7. 0, -2 is right here. What do you got going on? Going to the right. Should probably feel pretty good about that, right? And then what's it doing?
It starts going up, so you gotta end it.
So right there, it looks like I'm hitting vertical right here. End it. And 0, -4. Again. Heading that way. And again, ended. And again, you're just confirmation of that too, because when y is 0, the graph is undefined. So that should make sense right here. Y at 0, we've got undefined slope. What the values are up in the air. All right, jump to 8. Number 8. At 4, -4. So there's 4, 2, 3. That says -5 right there, but it means that's -5. Make sure you count correctly. So there's your -4 there. So 4, -4, somewhere right in this neighborhood. What do you see going on? Kind of coming up. And then what? Starting to head. Looks like I'm kind of veering off to the left, right? And again, I've got an equation, right? You can see right here, is this thing ever undefined? When x is 0, it's undefined, and you can see there's x is 0, so it totally makes sense that at this point, I'm just going to dive down there. But don't, every year I see somebody will come over here and they'll hit the high point, and they'll put an open circle. Remember, that's for undefined, not for 0. 0 is a perfectly solid number, right? Undefined, it doesn't exist. So we have to express that. Oh, and certainly I can go down. All right, so anyway, a little practice with sketching. Hopefully you look at those and you think, yeah, I'd be in good shape. Want to do a couple other things. Got a lot of little AP problems we could go through. So let's just plug through some. And if you have a question, let me know real quickly. Again, these would be, not quite sure why this is in red. Y'all have this, don't you?
Yeah.
Okay. So check out this one. It says consider the differential equation. Sketch the slope field at the 9 points indicated. You can see once again, they didn't put dots there on the vertical, mainly because at x equals 0, it is vertical, but they avoid that when it comes to sketching, so you can expect that. And then, so if you were sketching this thing, y minus 1, I'll write it up here. So if you were sketching this, help me out.
The 3 bottom ones are just 0.
So anytime,
Bottom, but on y equals 1.
yeah, anytime y is 1, which is this line I'm pointing at, when y is 1, these are all 0, so you can go ahead and put those there. The rest of those, I think I'm just going to have to suck it up, okay? So what about at -1, 0? At -1, 0, right? And if you need to do it,
Just -1.
write it out so you can see it. -1 over -1 squared is -1 over 1. So that's -1. So get that going if you need to eyeball what that would look like. All right, down 1 over 1. And what about at -1, 2? That would be +1. So again, rise 1, run 1, visualize that. At 1, 0. Still -1, right? At 1, 2.
Still +1.
Still +1. At 2, 0. -1 fourth. So at 2, 0, I got to go down 1, right 4, or I can go up 1, left 4. Now, and that to me, if I go up 1, 1, 2, 3, 4, I'm off the page. So how about go up a half, left 2? To me, that's a little bit easier to visualize. So it's pretty flat right there. You don't see a lot of that where you start getting denominators and numerators, their values have 4, because it's so hard to see between 3 and 4. And then finally, what happens at 2, 2? Well, +1/4. So again, pretty flat in there. So it says find the particular solution to the differential equation with the initial condition of that. So at 2, 0, what is the particular solution? So, getting started. Help me out. So you can cross multiply. I don't know, I'd probably just multiply by a dx because I want the x squared to stay there and divide by y minus 1. But that would give me this. right? Y'all see it? And then when I integrate, what do you suggest I do?
ln of y.
Now, remember what I said about if your u would have been y minus 1 and your du and your dy are exactly the same, like it's not du equals 3 dy, then what can you do? You can just kind of ignore the u substitution and just put the y minus 1 in there. But if that had been 2y minus 1, so that du is 2 dy, then no, you must do a u substitution. So after a while, maybe some of you I know have noticed that kind of stuff, but if you haven't, that is a little thing. And what about this x to the second? That's not natural log of x squared. It's
Negative 1 over x.
so I'm going to treat this as x to the negative 2, which gives me x to the negative 1 over negative 1, which is negative x to the negative 1, or negative 1 over x
Plus c.
plus c. And at this point, you got a point for separating variables, probably a point for each of the integrals, and a point for the constant variation. But sometimes I just say, if you don't have a c, the most points you can get is 2 points. And that's very common for them to say that. Okay, and at this point, I got to clean it up. And you'll notice right here what George said about this x to the negative 1 over negative 1. It is negative 1 over x. It happens so often, it's kind of worth knowing, but that ends up being a negative on the outside and x on the bottom. To me, it looks a lot better like that. And then you e both sides. Absolute value of y minus 1. Swing the c to the front. Absolute value gets eaten by the c. And then we can go back and find the c pretty easily. So when x is 2, well, actually not pretty easily. This is one of the ones that's actually a little ugly. Okay, so right here, if x is 2, so I'm plugging in 2, 0, I get negative 1 equals ce to the negative 1/2. So what's c?
Negative 1 over
Negative 1 divided by e to the negative 1/2, which is,
negative square root
y'all see that? Okay, that's true. Or you could just say negative e to the 1/2. Are y'all seeing that? Which is the square root of e. So that means that my equation is y equals c negative e to the 1/2, or negative square root of e, times e to the negative 1 over x. Add the 1 to the other side, which is not overly pretty. Now, that is totally fine to write like this on a free response. Y'all seen it? Can you see it? Totally fine to write on a free response. And also, if you want to write that as the square root of e, you could do that. And if you did it a different way, like if you solve for c up here, which actually wouldn't have been a terrible time to solve for. Check this out. I'm going to show you a different way. If you solve for c up here, you end up getting c is 1/2. But the c goes back there. Okay? Here, isn't that the same thing as saying like bases, add exponents? Isn't that the same thing? And that's why if you had solved for c right here, check it out. If I had plugged 2, 0 there, I'd be doing the natural log of the absolute value of negative 1, which is the log of 1, which is 0. And I would have gotten c as 1/2. And if I plug that 1/2 in there, and then I e both sides, I get negative 1 over x plus 1/2. That's what I have right here. I'm only mentioning that because every now and then, guys, these problems are multiple choice questions. And if they're multiple choice questions, you have to understand that your answer may not look like theirs, but it may still be correct. Doesn't matter here that AP readers are smart enough to know your algebra. But on a multiple choice, you got to be smart enough to go, wait, I'm just not going to skip this problem or choose none of these or just randomly guess if that's not an option, but that is. Remember, there are some actual different ways to write stuff, right? Okay, and then C said, for the particular solution, find the limit of that function as x goes to infinity. So for this solution, what is the limit? So here we go. I'm going to show you either way. here's the way I had it written. The limit as x goes to infinity of negative e to the half times e to the negative 1 over x plus 1. And the way they would have had it is, I think the way their key was, is negative e to the 1/2 minus 1 over x plus 1. How would you do the limit? So that's the only thing that's being affected right there, right? So if I plug an infinity in there, the exponent's approaching 0, and e to the 0 is a 1, and a 1 times that is that, and then plus 1. So yes, you get e, negative e to the 1/2 plus a 1. And the same thing here. If I plug an infinity in there, that goes to 0, and you get negative e to the 1/2 plus 1. So it's an ugly looking answer, and it really doesn't like instill confidence in my soul that I had done something right, because you're like, how, that doesn't feel normal, but that's correct. And you're going to see that on the AP test, and we'll talk tons more about that. But there are a lot of times you look at stuff and you're like, that just looks weird. And hopefully you won't think it's so weird by the time we get to the AP test, because you'll have seen it be weird so much, but still be right. But it is very common to get like points that are like pi, comma, pi minus 7. And that would be a coordinate for x and y. Weird things like that that you're plugging into an equation of a line or something.
So would this be an example of a 9?
Yeah, this is 9 points right here. This would have been 1 point. The B part would have been 6, most likely, and the slope curve would have been 2. But that's typically how they set those up. And they are very common. I mean, we've gone over a zillion of them. And I still have a bunch saved.
So
What? Say it again?
How does the scoring work with the slope field if you get one of the things wrong?
Yeah, I looked actually at this key or one very similar to it, and it said 2 points for the slope field, and it said one point was for marking the ones that were 0 correctly, and then 1 point for the other ones. And having not been a reader, I don't know exactly what they would have done, but I do know that they give half points out. So like if you missed probably one of the other 6, they might have still given you a half. But if you start making multiple errors on stuff like that. But yeah, they give you 1 point for marking the zeros. For some reason, they value that more, and then 1 point for the other ones. All right? All right, I'm going to show you another one that I thought was really dirty. And every now and then you get something like this, and especially when you have a differential equation like this, it's too bad. Because you're like, crap, man, I was looking forward to getting 6 points. But you can see in 2007, now this is Form B, by the way. Show up on time to take your test that day, because if you don't, you get Form B. And Form B, it just always screws you over just a little bit more than you want to. It's like they come up with 2 versions of every question, right? I don't know about the multiple choice, but on the free response, they come up with 2 versions. And they look at them and they go, which one's the hardest? And they're like, this one's a little harder. That's Form B. So if you miss for whatever reason, which there probably isn't going to be a lot of reason, with the exception of maybe if our test, sometimes it conflicts with the state track meet. That happens from time to time. But or if you have COVID. Yeah. If that happens, expect Form B. Now listen, I had somebody once in the middle of her test. Poor girl, like she walked out and I was like, you're gray. Like, she didn't look good. She's like, I don't feel so good. Blah. Yeah, and had to go home, and she missed the second half of the test. So we sent in her first half, and she had to go back and take the Form B, which was the free response, I think, or I forget. But whatever it was, she took it and still got a 5. So it's not like it's impossible, but you can see there's always like nickel and diming a couple little points out of you. It just feels that way. So check this out. It says consider the differential equation. And what do you notice immediately about that right now?
It has x and y.
Added together.
Yeah.
What does that mean? It means I don't know how to separate variables here, right? So that means you just missed out on a chance of solving that differential equation, which stunk because that's normally 5 or 6 gimme points in my opinion. Okay, so right here they're asking you different stuff. Now they are asking you to sketch the slope field, so we can do that. And then they ask you to do what? Find the second derivative, okay? And then they said, all right, if you have a particular solution to the differential equation at 0, 1, does f have a relative max, a relative min, a relative max, or neither? Justify your answer. What was it? Was this the one that I wanted to? Hold on. Let me see if this is the one that was super dirty. I wanted to show you that one.
I mean, this one kind of seems pretty dirty.
No, there was one that was super dirty. Like I literally had done it and yeah, this is it.
So we won't have one like this on our test.
Not Monday.
In 2007.
I was.
Oh, no, it's D that was so ugly. Okay, D. It said find the values of the constants M and B for which a line is the solution to the differential equation. I was like, what? And then when I looked at my answer, I actually had figured this out at some point. But when I looked at my answer, I was like, but these are the kind of things that now the upside is D was worth 1 point. So it didn't kill you or destroy you, you know. But let me just talk about this. So going to this thing, let's sketch the slope field real quickly. This is kind of a pain, and the slopes are all over the place. And actually, there is one way to kind of bail yourself out if you're really careful from the slope field. But let's take a look real quickly. So slope at, I don't see any real gimmies. Slope at 0, 0 is -1. Slope at -1, 0 is -1/2 minus 1, -3/2. So what's -3/2? Down 3 over 2 or up 3 left 2. It's kind of hard to go up 3 left 2. So I thought I'd go up 1.5 left 1. And that made it a little bit easier for me to visualize. Are y'all seeing what I'm doing? Instead of rising 3 and running a -2, I'm basically rising a 3/2 and running a -1. Kind of see my math on that? So instead of going, I can't go 1, 2, 3 over 2 very easily because I don't have those points, but I can split the 3 in half and I can split the 2 in half and I still get a proportional slope. So I'm just thinking creatively to help me use those points to visualize it. And then what about -1, 1?
Just -1/2.
So just -1/2. So at -1, 1, that's a little bit easier to visualize. And at -1, 2, +1/2. That's what I'm saying. These are all over the place. Up 1 over 2. 0, 1. 0, 1 is 0. 0, 2 is 1. 1, 0. 1, 0 is -1/2. So pointing towards that. 1, 1 is +1/2. Pointing towards that. And 1, 2 is so down 3 over 2 or down 1.5 over 1. So honestly, this is probably the ugliest AP slope field thing I've seen. But I did, and I was looking at it, I'm like, what in the world are the graphs even doing? Because it seemed like you were just kind of going all over the place. Okay, so that's the best I could do on that. I think that would be acceptable. And this says find the second derivative. So I'm going to come back to that. But it says find the second derivative and 1/2 x. Is that it? Okay, so it says find the second derivative. What do you have to do? So I'm going to take the derivative and it says describe the region in the plane in which all solution curves are concave up. Okay, so this is a key to part D. First thing, let's just find the derivative and get that, okay? So how do I take this derivative? That's the second derivative. How do I take the derivative of this? So derivative of that is 1/2. The derivative of y is 1 dy dx, or just dy dx, and the derivative of -1 is 0, and then what do I have to do with that dy dx? Plug that in there. So my second derivative is 1/2 plus that, and the 1/2 and the -1, when you plug that in there, give me -1/2. So let's see if we can answer that second part of the question. It says, does the function have, part B, describe the region in the plane in which all solutions, right, are concave up. All solutions are concave up. Now, what does it mean if the solution's concave up?
F prime is increasing, or F double prime is positive.
F prime is increasing, or F double prime is positive. So this is what?
Greater than 0.
Greater than 0. And if that's greater than 0, describe the region in the plane where it's greater than 0. Well, I could say this, and I think you probably got credit for it, but this is what's important. It's going to help you on part D. If I solve for y, y is greater than -1/2 x plus 1/2. So what does that mean to you?
Nothing.
That's the shaded region above that line.
Okay.
So the shaded region on this slope curve, the shaded region above that line is always going to give you concave up situation. Now, with that in mind, where would it be concave down?
The other bits.
The part below, right? Where would it be neither?
On the line.
On the line. Now, I didn't think about that yesterday when I was looking over this problem. I was like, what?
Oh, so is that line just part B?
Yes. So part C says, let y be a particular solution to the differential equation. I don't know what it is, and I don't have the ability to do that with what we learned in Cal 1. In differential equations, that's another story. If you take that in college, you'll spend a whole semester looking through ways to go from a derivative back to a function. But we don't know that in algebra, and they didn't ask us to find it. But they did say, does whatever that function is, does it have a relative maximum or neither at x equals 0? Now, what do you know? At x equals 0, that's a point, right?
Plug it in.
So the point 0, 1. Now, how can I use a derivative or a second derivative to determine whether I have a relative max or a min? And can I justify that answer?
Yeah, it's the
Second derivative test. We're going way back, and we'll review all that again. Now, remember, the second derivative tells me where a function has concavity, right? And if the second derivative is positive, we know a graph is concave up. If the second derivative is negative, we know a graph is concave down, right? Concave up, concave down. And if there was going to be a max, where would it have to occur? Where it's concave down. Are you with me? So right here it says, let me have a particular solution with the initial condition of 0, 1. Does the function have a relative max, min, or neither at that value? So if I plug 0 and 1 in there, 0 right there for x and 1 right there, what happens?
Right.
Yes.
Isn't that only if you use the differential equation, not the second derivative equation?
Say it again.
Like when plugging in 0, 1, wouldn't you have to plug it into the original 1/2 x plus y minus 1?
Well, I do need to do that, and I should have, to make sure it's a critical number. But if I plug that into that equation, go back in here. If I plug 0 in there and 1 in there, what do I get?
0.
The derivative is 0. So I know it's a critical number, and that's important on the second derivative test. So yes, plugging it in there, so I could say yes, because at 0 or 0, 1, I know there's, yeah.
Why did the second, equation that's 1/2 x plus y minus 1/2 get down? Why is that 1/2 negative?
Oh, because I plug this right here and then simplified that.
Oh, okay.
Yeah. So with the second derivative test, so my justification would be because of the second derivative test, okay? And because 0, 1 is a critical number, and you probably want to show that, right? Say something like dy dx at 0, 1 is 0, therefore 0, 1 is a critical number. So you know it's a critical number, and then when you plug 0, 1 into that function, what happens? Into the second derivative, when you plug 0, 1 in there, yeah. So in the second derivative, at 0, 1, you get 1/2 plus 1 minus 1/2 is 1/2, which is positive, right? So you now know, because it's a critical number and because the second derivative is positive, you know that because of the second derivative test, you know that at 0, 1, you have f of x has, or y has, a relative min. You seeing that? Because you know, because the second derivative is positive, you know that it's concave up. Because it's concave up at a critical number, you know that there's a relative min there, although you don't have to say all of this because that's what the second derivative test says. So you know you have a relative min there. Yeah, this is one of, to me, it's Form B, man. Stay away from Form B. Just be there on test day. And you get these little brutal ones show up less and less. And then part D says the values of, find the values of the constants where the line is a solution. And when I first saw that, I was like, what? And I actually got lucky. I went back here and I went, well, back to my slope field. Where can I get a line going through here? Sure as heck isn't that. It's not that. It's not that. It's not this. And I went, wait, both of those are -1/2. So I checked another one. What would happen if I plug a 0, 1/2 in there? I plug a 0 and a 1/2. Oh, also a -1/2. And I got really, really lucky. And I said, oh, well, looks to me, and I could plug in all kinds of other little things to check that right on the money. But I said, oh, it looks like -1/2. That would be at y equals slopes -1/2, crosses at +1/2. But you don't have, that's not using calculus, that's using blind dumb luck. What do you know about lines in reference to concavity? They don't have any. And we already discovered that this thing was concave up when it was greater than this line. It was concave down when it was less than that line. So it's no concavity when it is that line. So if I have to justify my answer in part D, I can't say, it didn't ask me for that, it just gave you credit for being right. But if I had to justify my answer, I can't say, because of good, solid, dumb luck, I happen to notice that on your slope curve. I'd have to say, well, lines don't have concavity, and the only place this curve doesn't have concavity is at that, based on the second derivative that I found. Got track with me? So believe me, they can be brutal, but that's 2007. And I have not seen something that ugly. I think every year, without question, there's been at least a 4, but normally a 5 or 6 point problem on the free response. And when there's not, that year that had 4 or the one year it was omitted, it showed up 3 or 4 times on the multiple choice part where you had lots of opportunity to take do the differential questions. They really value these points and you doing them. All right. What do we got?
4 minutes.
4. Is there anything else that I want to show you? All right, look at 2005. We're just going to do one part of it. Look at part B. This This is often a very big part of this. Again, I don't think I'm going to ask you this kind of stuff tomorrow, probably. But it says, part B says, obviously you're doing a slope field, you get down to part B, write an equation for the line tangent to the graph of this function. Right? So I don't know what the function looks like yet, but I want one tangent to the graph at x equals -1.
So you have to find the general solution.
Nope.
No?
If I want something tangent to the graph, what do I need to find tangent to the graph?
A point and a
A
slope.
point and a slope. Do I have a point at -1? They gave it to me. -1, 2. Do I have a slope at -1?
Yeah.
Well, not yet, but I have the slope equation. That and show it into this. So -1, 2 squared over 2 gives me 2. And I've got a point and a slope, and I'm on my way. So y minus the 2 equals 2x plus the 1, and I don't ever go further than that. Right? And believe me, that's definitely something. It'd be like a 1-point problem, but this would be like your version A 1-pointer that they ask you. And you saw what they do too on version B. They always are, not always, but almost always, if you're going to see a little uglier problem, you'll look up and you'll see form B up there. And then again, find the solution to the differential equation, more of the same. All right? All right. Well, you got a 2-day weekend. I'm sure you'll study throughout the whole weekend and prepare yourself adequately. And I'll see you then.
All right, she's trying to get Victoria to do something more. She hasn't.